Good afternoon. The Subcommittee on Energy will come to order. Without objection, the Chair is authorized to declare recess of the Subcommittee at any time. And welcome to today's hearing entitled Unleashing American Power, the Development of Next Generation Energy Infrastructure. I recognize myself for 5 minutes for an opening statement. Good afternoon. Today, the Energy Subcommittee will examine the Department of Energy's role in accelerating next-generation energy infrastructure research and development activities in areas like grid security, pipeline innovation, and hydrogen research and development. This hearing will also serve as a legislative hearing for 3 bills that would update Department of Energy's R&D efforts in these areas. Recent Science Committee legislation, such as the Energy Act of 2020 and the CHIPS and Science Act, have authorized programs at the Department of Energy to meet the growing challenges of our time. But there are some serious gaps left specifically in energy infrastructure research and development. Without comprehensive authorizations by Congress in these areas, the U.S. may risk falling behind our global competitors. From powering our homes and businesses to fueling transportation systems, the U.S. power grid and pipeline systems are integral to our long-term economic success, as well as our national security. This infrastructure connects producers to consumers, powering our homes and businesses, but it was built decades ago, in many cases, and this aging system wasn't constructed with modern challenges in mind, such as cybersecurity and the surging electrification of our economy. Grid security is national security. The DOE's Office of Cybersecurity, Energy Security, and Emergency Response, known as CSER, bit ominous, I think, is tasked with modernizing and securing our grid. CSER's partners with the national labs, universities, and nonprofits, as well as industry, to identify potential vulnerabilities, to create processes to detect cyber incidences, and to develop technologies that strengthen the grid. DOE also supports test beds at national laboratories that provide researchers and industry-unique opportunities to test different tools, methods, and technologies, including distribution automation, smart grid devices, and communication tools, all without impacting existing customer service. As our energy sector faces increased threats and hazards, it is imperative that Congress provides DOE with updated guidance to ensure the Department can meet the challenges of tomorrow, providing better service for customers and reducing blackouts. Working in tandem with the electric grid, pipelines are the vital arteries of the U.S. energy system, providing cost-effective and reliable power to Americans across the country. The Department of Energy's Office of Fossil Energy and Carbon Management and the Department of Transportation's Pipeline and Hazardous Materials Safety Administration are leaders in fundamental pipeline research and innovation. Their work includes, but is not limited to, developing advanced materials, coatings, and sensors, testing different blends, and improving leak detection and pipeline repair technologies. Despite these efforts, Congress has yet to pass a comprehensive authorization of DOE's pipeline R&D activities. Future legislation, which is part of what we're covering today, should build on efforts that improve safety, increase efficiency, and particularly extend the lifespan of existing miles of pipelines across the United States. For example, in my home state of New York, we have over 500 miles of natural gas transmission pipelines, and we should have much more. We also have 1,100 miles of crude oil products and natural gas liquid lines, which allow my constituents to access reliable, resilient, and affordable energy. However, in recent years, New York state officials have stifled at least 3 pipeline development projects, and as a result, New York consumers and households pay 51% more for electricity than the national average. Further direction from Congress would ensure pipeline resources that are available for generations to come. Another area of investment for our energy infrastructure future is hydrogen, a potential source of low-cost energy. Hydrogen is an abundant element that may prove useful to power our economy and store excess energy. Currently, hydrogen is used in industrial applications to produce common chemicals such as ammonia, but is primarily produced by fossil fuels. Hydrogen has a wide range of potential uses and can be generated from other energy sources such as renewables and nuclear. We will talk about some of that today. Importantly, hydrogen could prove useful in carbon sequestration of methane and thus help America achieve our emission goals. This month, 9 Mile Point Nuclear Station in Oswego, neighboring my district, became the first nuclear facility to produce clean hydrogen through a Department of Energy demonstration program. Codifying these kinds of public-private partnerships in law is key to the development and cost-effectiveness of hydrogen. DOE's hydrogen and fuel cell activities have not been fully reauthorized in over 15 years. There is an urgent need for updated congressional congressional direction in this area. With reauthorizations of grid security, pipelines, hydrogen R&D, I am certain that the DOE, along with partners at the national labs, universities, as well as industry, will lead us towards a path that unleashes American energy and delivers prosperity and affordable energy for all citizens. I want to thank our witnesses for their testimony and look forward to our conversation. I now recognize the ranking member from the gentleman from New York, Mr. Bowman, for your opening statement, sir.
Thank you so much, Chairman Williams, for convening today's hearing. While I would like to give attention to each topic, I must first celebrate my home state of New York for leading the way by enacting legislation this past December that will create the strongest in the nation cybersecurity protections for my state's energy grid. This action, taken during a global surge in cyber attacks against critical infrastructure, will help ensure New York's grid remains reliable and secure as we move quickly to 100% clean energy. I also want to recognize the bipartisan grid security bill led last Congress by my colleague, Congressman Bera, which supports federal R&D to advance solutions to protect our nation's electric grid systems from a range of attacks. I hope that my Republican colleagues will continue to support Mr. Bera's important legislation this Congress. Now I'll turn my attention to the other two topics for the hearing, pipelines and hydrogen. I chaired our subcommittee's hearing on hydrogen last year, and my cautiously optimistic stance has not wavered. Today, I restate my view that green hydrogen, produced with 100% clean energy, has the clearest potential to help meet our climate goals in certain sectors. And when hydrogen is made from fossil fuels, we should not call it clean. Grassroots communities and experts are sounding the alarm about the fossil fuel industry's overreach here, and we in Congress should listen. To be an effective climate solution, hydrogen must be produced cleanly and used wisely. I recognize that hydrogen could significantly decarbonize heavy industry like steel and cement production and may have some other important applications. However, this energy source is not a climate solution if it harms local communities. Most of the hydrogen available today is made from methane or coal, and blended hydrogen methane gas is proving to be more dangerous than methane alone. Yet, across the country, utilities and gas companies suggest this is a part of their near-term decarbonization strategy, apparently ignoring the continued energy and health burdens on low-income communities. Research has established that the transportation of hydrogen and hydrogen blends by pipeline has unique risk, particularly in the distribution lines that connect to the buildings we live and work in. We are also just learning that hydrogen generally has more significant warming potential than is typically recognized and is easily leaked. These facts cannot be overlooked by hundreds of billions of dollars in public and private investment are primed to fund nearly 700 global proposed hydrogen projects. No one believes in the urgency of providing climate solutions more than myself, but I encourage my colleagues to proceed with caution. We must seek to understand better the impact hydrogen may have on our atmosphere and chart a path forward where hydrogen is deployed as a safe, strategic, and truly clean energy solution. Better understanding not only the technical gaps, but also the environmental impacts is absolutely necessary. That said, I hope you'll join me today in asking the difficult questions that we should be asking about this emerging industry and on the best ways to ensure that we minimize and ultimately eliminate the negative impacts of current and any future pipelines used for these and other purposes. I look forward to hearing from our witnesses. Thank you so much for being here, and I yield back.
Thank you, Mr. Bowman. Unfortunately, the chairman of the full committee, Mr. Lucas, could not attend the hearing today for personal reasons, but I would like to submit his opening statement for the record. I now recognize the ranking member of the full committee for a statement.
Thank you, Chairman Williams, for holding today's hearing, and thank you to our panel of experts. I look forward to hearing your testimony. We're here to discuss several important energy technology areas, but I'd like to focus my remarks this morning, or actually this afternoon, on grid security, resiliency, and capacity. You know, this topic is one that hits close to home. We're near the 10-year anniversary of the Metcalf Transmission substation sniper attack that was in my district, is still in my district. At the time of that sniper attack and the cutting of transmission lines, the then chairman of the Federal Energy Regulatory Commission, John Wellinghoff, said that the attack was, quote, the most significant incident of domestic terrorism involving the grid that has ever occurred in the United States. Since then, we've been able to integrate advanced technologies into the grid, which widens the realm of possibilities for physical attacks on the grid. Not to mention cyber attacks. I know everyone here thinks of the Colonial Pipeline ransomware attack less than 2 years ago. We can fortify the grid through the deployment of existing technologies and via a standards development and implementation, but there's a gaping research and development need here as well. As was mentioned by the ranking member of the subcommittee, Mr. Baer has introduced legislation in the last 3 Congresses to address the research needs. Not only would advancing grid security R&D help prevent physical and cyber attacks on the grid, it would help address needs to fortify the grid against other types of physical damage, such as caused by wildland fires. More broadly, we need to be doing everything we can, not only to ensure the security of our grid, but also the capacity of the grid as we expand its capacity to harness the next generation of clean energy technologies, like fusion energy. There's bipartisan support on this committee and in the Congress for expanding and supporting the science on fusion so that we can eventually get to the energy production of fusion. If we don't address the capacity of the grid, that energy source, along with all the other energy sources that are clean, will not be efficiently distributed. So I look forward to listening to all of the members. As was mentioned, Mr. Tonko introduced important bipartisan legislation with Ms. Weiss late last year to advance the next generation of hydrogen technologies, and I welcome any thoughts any of you may have on that bill. I'm interested to learn if there's more research needs in that area, which was the subject of the another bipartisan bill by another member of the Science Committee, Mr. Casson. So thank you again, Mr. Chairman, for recognizing me, and I yield back the balance of my time.
Thank you, Ms. Lofgren. Well, we're very pleased to have distinguished witnesses here today, and again, thank you so much for taking the time, making the effort to prepare and help us with these difficult issues. Let me just take a moment to introduce our witnesses. Our first witness today is Mr. Spencer Nelson, Managing Director for Research and New Initiatives at ClearPath. Our next witness is Dr. Richard Boardman, Directorate Fellow at Idaho National Laboratory's Energy and Environmental Science and Technology Directorate. Our third witness is Mr. Cliff Johnson, President of the Pipeline Research Council International. Our next witness is Dr. Arvind Ravikumar, co-director at the Energy Emissions Modeling and Data Lab and Research Associate Professor at the University of Texas at Austin, Department of Petroleum and Geosystems Engineering. Our last witness is Mr. Jason Fuller, Chief Energy Resilience Engineer at Pacific Northwestern National Laboratory. I now recognize Mr. Nelson for 5 minutes to present his testimony.
Good afternoon, Chairman Williams, Ranking Member Bowman, and members of the committee. My name is Spencer Nelson. I'm the Managing Director of Research at ClearPath Action. We advocate for clean energy innovation, modernized permitting, and American leadership. Thank you for the opportunity to testify today. I'll cover 3 key themes. First, how innovation leads to lower costs and lower emissions. Second, the need for more research and development for grid resilience, hydrogen, and pipelines. And third, opportunities for industrial decarbonization and carbon dioxide removal. American ingenuity has driven down the costs of natural gas and renewable technologies over the last decade, all of which now provide affordable clean energy. None of these would have been as cost-effective today without U.S. investments over the last 50 years. The shale gas boom in America is a perfect example of successful public-private partnerships. In the 1980s, Texas entrepreneur George Mitchell figured out how to break up shale rocks to release the natural gas stuck inside. This process, called hydraulic fracturing, initially got off the ground with support from DOE, which cost-shared research and development and demonstrations in the 1970s and 90s, as well as tax credits into the early 2000s. Now we have a $100 billion annual shale gas market in America, which is not a bad return on DOE's initial investment. The U.S. is uniquely positioned to lead global action on emissions reductions, creating jobs in new industries, and reasserting America's global leadership over our rivals. One of the best policy examples is the Energy Act of 2020. The Energy Act, which came through this committee, refocused DOE's R&D programs to scale up clean technologies like advanced nuclear, long-duration storage, carbon capture, and geothermal. Many of these programs were later funded in the bipartisan infrastructure law and are now being implemented by DOE. So far, DOE has awarded over $7 billion across 37 demonstration projects, and there's still $55 billion remaining to be awarded. Another important bipartisan law was the CHIPS and Science Act, which invested in basic science, technology transfer, and low-emission steel research and development. And while the Energy Act and CHIPS and Science are each significant, today's 3 important topics of grid security, hydrogen, and pipelines still require additional legislation. The power system in the U.S. consists of more than 7,000 power plants with millions of miles of power lines which ultimately connect 145 million customers. The bulk of that system is over 40 years old, and threats to the system continue to grow. The grid security discussion draft before us today addresses the need to secure our nation's energy systems from cyber and physical attacks, as well as extreme weather events through a comprehensive research and development program. Another crucial technology area is clean hydrogen. When developed responsibly, hydrogen produced from renewables, nuclear, or fossil energy with carbon capture can play a key role in reducing emissions while strengthening our energy security. Earlier this month, the 9 Mile Point nuclear plant in upstate New York, in Representative Tenney's district, started producing clean hydrogen on site. In Louisiana, Air Products announced a $4.5 billion clean hydrogen project that will sequester over 5 million tons of CO2 per year. The clean hydrogen discussion draft would fully authorize research and development programs for the first time in 15 years. With additional research and careful project development, hydrogen does have the potential to be an affordable, abundant, and clean energy source. Finally, there's the discussion draft on next-generation pipelines. Pipelines are an essential part of the U.S. economy, transporting over $45 billion of U.S. GDP in 2021. Transporting products by pipeline has over 40% fewer emissions than by rail and has a better safety record. If enacted, this discussion draft would improve public-private partnerships and increase R&D and demonstrations of next-generation pipelines. In addition to today's bills, this committee should also consider policies for industrial processes like cement and concrete, as well as novel carbon dioxide removal technologies. Globally, emissions from cement production are higher than the entire nation of India. So smart new R&D policies could be a win-win, creating jobs here at home while positioning the U.S. as one of the most carbon-efficient cement producers in the world. Recently enacted policies like the Super Act will develop low-emission steel, and similar legislation would help the cement and concrete sector as well. Since cement naturally releases carbon dioxide during the production process, its emissions cannot be eliminated through renewable energy alone. We need new legislation to explore the full variety of R&D options available. And even with these exciting innovations, most climate projections still call for carbon dioxide removal from the air. Globally, that could mean that we need more than 10 gigatons of carbon dioxide removed per year by 2050. One bill that would help carbon removal is the CREST Act, which was introduced last Congress. The CREST Act includes R&D expansions into new areas of technology, as well as a carbon removal commercialization program. To conclude, this committee has an incredible record of bipartisanship and clean energy innovation. ClearPath Action appreciates this committee's accomplishments, and we look forward to supporting your efforts in the months ahead. Thank you for this opportunity, and I look forward to the discussion.
Thank you. I now recognize Dr. Boardman for 5 minutes.
Thank you, Mr. Chairman Williams. And Chairman Williams, Ranking Member Bowman, and members of the committee, I'm a chemical engineer and a directorate fellow at the Idaho National Laboratory, the nation's applied laboratory supporting nuclear research, sustaining our existing fleet, and developing advanced reactors. I believe the draft bills under review today have important bearing on our national security by providing greater energy security, greater economic strength and stability, while taking a significant step towards environmental sustainability in a manner that will bolster business, create jobs, improve the quality of life for many living in urban communities and for those living near large power generation and manufacturing facilities. Related to all three bills, INL's mission is focused on securing our nation's critical infrastructure and ensuring its cyber and physical resiliency. INL's technical expertise in cyber-informed engineering and critical function assurance are a vital part of a national cybersecurity strategy. In the last decade, DOE has invested nearly $40 million establishing one of the nation's most comprehensive electric power grid test beds at the Critical Infrastructure Test Range Complex in Idaho. The complex is being used to prove new concepts and technologies to protect the nation's most critical electric infrastructure. Cyber-informed engineering is an important aspect of building secure hydrogen plants, especially those that will be closely coupled to nuclear plants. I believe 4 conditions must be in place for clean, emissions-free hydrogen systems to be established and then expanded without subsidies. First, we must have low-cost hydrogen production technology. I'm confident the U.S. is on a path to reduce the cost of electrolyzers, as well as blue hydrogen produced from natural gas with carbon emissions mitigation, to reach the goal of producing clean hydrogen for under $2 a kilogram by 2026, or in just 3 years, and approaching the Earthshot goal of $1 a kilogram by 2031. With continued support from DOE, electrolyzer costs will be reduced through higher performance and longer durability. The BIL will help establish high-volume U.S. manufacturing on a scale that is necessary to reduce the cost of the electrolyzers. High-temperature electrolysis is particularly well-suited to nuclear energy because it can take advantage of heat and electricity that can be generated by nuclear reactors. Idaho is helping industries like Nexeris, Oxyon, Cummins, Fuel Cell Energy, and Bloom Energy, all American companies, validate high-temperature steam electrolysis with stack and integrated systems performance testing. Blue hydrogen will be competitive as long as the price of natural gas remains low and carbon sequestration costs are minimized. Hydrogen produced by water-splitting electrolyzers will be competitive when it is coupled to inexpensive renewable power that will be available during periods when there is excess generation. Idaho National Lab has shown that the electricity from an existing nuclear plant can also be used to produce competitively priced hydrogen. I'm sure that most of you are aware of the 3 industries, DOE cost-shared projects, one of them referred to Chairman Williams. Just started producing hydrogen at one of the Constellation nuclear plants in upstate New York. Next year, Energy Harbor in Ohio will start producing hydrogen at the Davis-Besse plant. X-Energy in Minnesota will be the first to send both thermal and electrical energy to a commercially provided steam electrolysis module. The virtue of nuclear reactors are they reliably produce clean power through all hours of the year. With the advent of advanced microscale and small modular nuclear reactors, hydrogen can be produced on location for process industry users. This will eliminate hydrogen delivery costs and infrastructure. Industry is enthusiastic about the potential for low-cost hydrogen. I could mention many companies who have now come forth, whether they are the petroleum industries, the steel industries, power generation industries, including GE, that's working on a hydrogen-burning turbine, which could cite as many as 1,500 land-based, several more in aviation-based applications of this hydrogen. They're all have an eye on this clean source of hydrogen coming. So it will move steel, fuels, ammonia, and power generation and energy storage. And I think it is critical to how we will be able to store energy and allow renewables to be built up and coordinate that use with other clean energy sources. So with that, I wish to thank you for my time to be able to speak to you today.
Thank you, Dr. Wordman. I now recognize Mr. Johnson for 5 minutes to present his testimony.
Thank you very much.
Sir.
Good afternoon. Oops. Sorry about that. Good afternoon, Chairman Williams, Ranking Member Bowman, and the members of the Energy Subcommittee. My name is Cliff Johnson. I'm the president of the Pipeline Research Council International, and I'm very excited to be here today to testify and comment on these bills. PRCI was founded in 1952 to solve key challenges that face the safety and integrity of the energy pipeline network in the United States. Over the past 70 years, we have grown into the global nonprofit that performs research needed to advance the safety and integrity of our global pipeline systems. Our mission is to collaboratively develop and deliver relevant, innovative, applied research to continually improve the global pipeline systems. PRCI is recognized around the world as a unique forum within the industry for delivering great value through the development, deployment of research solutions to improve pipeline safety and performance. We've worked closely with the U.S. Department of Energy, the Pipeline Hazardous Materials Safety Administrations, the Environmental Protection Agency, National Institute of Standards and Technology, also our partners in Canada, the Canada Energy Regulator, Natural Resources Canada, and most recently, the Environment and Climate Change in Canada as well, to begin working across the industry and government together in a public-private partnership to advance integrity and safety. We also have very strong partnerships with sister organizations in Europe and Australia. One thing I have to say is that pipelines don't care where it is. Steel is steel. You need to make sure the safety is there globally. Today, though, we're at a really unique crossroads. Both in the U.S. and globally, we are working aggressively to develop the next generation of fuels. As we begin looking to this next opportunity, today it's hydrogen. We need to think about the safety and the integrity of the systems that we will be doing. With that in mind, we need to remember that the most important asset here is the pipeline infrastructure. Still the safest, most efficient transport mode there is in the world. Pipelines will continue to be the backbone for our industry to move this vital resource. The members of PRCI and the industry continue to innovate this network towards zero emissions and 100% reliability. I'm excited to say that PRCI has been at the forefront for a number of transitions throughout our life. We were founded in 1952. We were some of the earliest researchers in hydrogen, looking at ethanol and other biofuels as well. Our industry has continued to look for the other sources of energy that we need to have as part of our mosaic of energy to fulfill the various demands that we have. In 2020, PRCI created the Emerging Fuels Institute to enable the oil and gas industry to begin exploring how can we move hydrogen in the systems that for so long we tried to maintain out of our systems. Hydrogen has a negative impact on the steel, and how do we get this in a new process moving forward? PRCI has also taken a leadership role and brought in 20 companies from around the world to be part of the Emerging Fuels Institute. We also partner with 4 international organizations to support our mission and our vision in this space. We're at a point where the research needs to progress further, faster. We are unique in that this time around, we aren't driving the conversation of when we need the next energy source. We're actually have some real world expectations in us soon. As was mentioned briefly a minute ago, 2026, 2030, 2050 are those deadlines. To achieve that, we need to move much more rapidly and in a partnership approach, the collaborative approach, through a public and private partnerships. As was mentioned earlier, there are some challenges with moving hydrogen in our current systems that we need to be very mindful of. And we need to make sure that the research is there as we begin to move this new product in our systems. It is doable, but the research is definitely needed. Some areas, just to give an example, one is the equation of state, some of the technology around what does it look like when we put hydrogen together with natural gas and what does it impact on the steels. Looking for new ideas on how do we understand the material properties, which is one of the key limiting factors of putting hydrogen in our system, is how does it impact the steels. As we continue to look at our steel production and the opportunities, we need to think about our current assets. Much of our systems today are older than 60 years old. How do we maintain those into the future as we continue to need those assets to be there for us when we need to? PRCI has begun to aggressively move through this space, and we have a technology center that we developed in Houston, Texas, the first of its kind in the world to really drive this conversation. So as the pipeline bill today considers this new center, let's look together, how do we work together to really elevate and execute this opportunity? Again, today, we're excited about the opportunity to talk about collaboration, how the industry and the government can work together to improve the safety and integrity of this vital network. Thank you again for this opportunity to present. I look forward to answering any questions you may have and look forward to the opportunity to learn more about where you're going and how we can help. Thank you.
Thank you, Mr. Johnson. I now recognize Dr. Ravi Kumar for 5 minutes for your testimony, sir.
Thank you. Chairman Williams, Ranking Member Bowman, and members of the Energy Subcommittee, thank you for this opportunity to testify today on these critical topics. I'm Arvind Ravikumar. I'm a co-director of the Energy Emissions Modeling and Data Lab at the University of Texas at Austin. Over the past decade, I've led several large-scale field campaigns in the U.S. to measure methane emissions from the oil and gas supply chain. In addition, our research group has evaluated many innovative technologies, such as drones, satellites, and aircraft-based systems for detecting emissions from natural gas infrastructure. Throughout my research, I've worked in close collaboration with the industry, state and federal agencies, and non-governmental organizations. The United States by far leads the world on both technology innovation and direct measurements of carbon emissions from oil and gas infrastructure. Voluntary industry efforts, federal research programs, and other field campaigns have all contributed to a significant body of work on supply chain carbon emissions. This matters for 3 reasons. First, we know the gaps in research that need to be filled across both the natural gas supply chain as well as emerging areas such as hydrogen. Second, as the largest exporter of liquefied natural gas, or LNG, transparent information on supply chain carbon emissions gives U.S. exports a significant advantage over other suppliers. Third, our continued and long-term investments in research related to methane emissions measurements have supported dozens of new startups and small businesses that have created high-paying jobs across the U.S. While we have made tremendous progress on understanding methane emissions broadly, direct measurements from the pipeline network, especially gathering lines and transmission pipelines, are still lacking. Recent evidence from the Permian Basin in Texas suggests gathering lines are a significant source of emissions and can be fixed cost-effectively. Regional basin-specific studies on pipelines would close the gap in their supply chain emissions measurement portfolio. The Department of Energy has been historically successful in supporting technology innovation and leak detection. Many of the early-stage technologies supported through the agency over a decade ago are now some of the fastest-growing companies in the emissions detection space. We are now in a new phase of technology development that will focus on networked continuous monitoring systems, autonomous drone surveys, and inline measurements that will make use of advances in machine learning and data analytics. The Department of Energy, in collaboration with NIST and PHMSA, should fund research on these next-generation sensor technologies and develop comprehensive multi-scale modeling and data analytic capabilities. In addition, the U.S. also needs expanded test facilities to evaluate new sensor systems that will operate across a wide variety of facilities, geographies, and weather conditions. This will ensure that we continue to lead the world in technology development, evaluation, and deployment. Furthermore, these test facilities could be designed to simultaneously evaluate infrastructure for the growing hydrogen economy. Now, hydrogen is a key element of U.S.'s future energy system. A key area of research is understanding how we can use existing natural gas pipelines for transporting hydrogen. Repurposing existing infrastructure reduces costs, lead times, and enables rapid deployment for hydrogen end uses. However, several open questions remain. Hydrogen leaks pose a safety as well as an environmental risk. Understanding how hydrogen leaks occur in natural gas pipelines, how different blends of hydrogen and natural gas affect transport properties, and how the presence of hydrogen impacts materials used in pipelines are all critical areas of research. Research should also focus on funding new technology and sensor development, new materials that can withstand the corrosive effects of hydrogen, and innovation centers that identify and solve challenges associated with integration of hydrogen with conventional energy systems. A key aspect of hydrogen production is a variation in cost, emissions, and storage and transportation infrastructure across the U.S. For example, blue hydrogen production has a significantly lower emissions profile if produced in Marcellus Basin in Ohio and Pennsylvania compared to the Permian Basin in Texas. Furthermore, pipeline capacity limits in the Permian Basin favor production of methanol as a hydrogen carrier, which is a liquid, instead of hydrogen gas that would require additional pipelines. Permian production could also benefit from abundant solar and wind resources in the region. Thus, the form of hydrogen production, transportation, and end use will vary across the U.S. and must be tailored to unique regional strengths. The Department of Energy should support research on detailed geospatial and region-specific studies to identify regionally optimized approaches for hydrogen production, transportation, and end uses that maximize benefits to the region's economy. Finally, the success of these efforts will rest on our ability to develop effective and trusted carbon accounting systems across energy supply chains. As the largest exporter of LNG and potentially of hydrogen, the U.S. has a vested interest in demonstrating the environmental and economic benefits of U.S. energy supply chains over other suppliers. Carbon accounting that is not transparent with measurement data or analytical systems will make it challenging to build trust on the global stage. The Department of Energy has a key role to play in supporting public-private partnerships to collect, interpret, and make public supply chain emissions information across U.S. energy infrastructure. In summary, continued investments in our pipeline infrastructure and hydrogen technology will ensure that the U.S. continues to lead in energy research and development with broad-based benefits to the industry, consumers, communities, and the environment. Thank you for your time, and I look forward to your questions.
Thank you. I now recognize Mr. Fuller for 5 minutes to present your testimony, sir.
Good afternoon, and thank you, Chairman Williams, Ranking Member Bowman, Ranking Member Lofgren, and members of the subcommittee for the opportunity to speak on behalf of basic and applied research objectives and how they relate to the protecting of cyber and physical security of the nation's electrical grid. My name is Jason Fuller. I've been a power system research engineer at Pacific Northwest National Lab for 14 years, focused on power system modeling. And for the last years, I've had the opportunity to serve as the infrastructure modeling lead for DOE's North American Energy Resilience Model, analyzing cross-sector dependencies on electrical resilience and the impacts of natural and man-made threats to electrical operations. Today, I'd like to focus on 2 comments. First, the evolving nature of the nation's electrical infrastructure and the increasingly complex threats it faces requires continued investment in cutting-edge research, development, and deployment to maintain both our nation's competitive advantage and its overall security. But our electrical industry is facing a number of changes all simultaneously. Our electrical system is transitioning from an earlier, simpler era dominated by large generation stations and passive energy loads to an active, intelligent, and distributed system often driven by customer or third-party owned assets that are outside of the traditional utility control network. This includes such technology as energy storage, solar photovoltaics, electric vehicle chargers, or smart thermostats. These devices are introducing new uncertainties in the system, but also new opportunities. New control methods and grid architectures, new incentive structures, and secure communication systems to support these are needed to ensure our system continues to stay reliable, resilient, and secure. Changes associated with our climate have resulted in prolonged droughts, devastating wildfire seasons, more intense storms and hurricanes, and extended cold and heat wave events in areas that have never seen them before, requiring utilities to change their planning criteria. New capabilities are needed to translate climate prediction models into localized extreme weather impacts, and in the end, into actionable decision-making for utilities and regulators, with a particular focus on how to evaluate cost versus resilience trade-offs, and how those trade-offs impact individual customers. Continued development of technologies that minimize outages, prevent damage, or create additional system flexibility with an eye towards these future extreme weather patterns are essential. And on top of this, foreign actors are well aware of the critical nature of our power system, and it has long been considered a logical target for major intrusions, whether physical or cyber. This battle is an ever-evolving conflict, with defenders constantly needing to adjust and create new defenses. Public-private partnerships are needed to strengthen and protect our supply chains, provide tools for utilities to assess system vulnerabilities and risks, advance our human-machine intelligence for detection, discovery, and situational awareness, and enhance our automated responses. The federal government also has a role to prepare tomorrow's workforce for these challenges and support smaller utilities that may not have access to the necessary resources. My second comment is that both basic and applied research are an integral part of innovating new methods to predict, monitor, and defend against potential threats, and then mitigate the impact of those challenges. Federal investments in research drive innovation and advancements in the next generation of technology to protect our system from these ever-evolving challenges. So let me give you a couple of examples to illustrate my point. Developments in linear solvers and optimization algorithms from predecessors of the Office of Science's Advanced Scientific Computing Research Center are at the core of current software running in electric control centers across the country, providing enhanced visibility and accelerating necessary calculations to better understand the real-time behaviors of the system. But as I mentioned, the system is changing. So new developments utilizing exascale computing under a 5-lab SGD project are testing algorithms on Oak Ridge National Laboratory's Frontier exascale computer to incorporate the initial uncertainty brought by millions of new edge devices and variable generation, while thinking about thousands of threat scenarios to ensure continued integrity, security, and economic operation of the power system across a wide range of future challenges. The new grid storage launchpad is a critical facility to accelerate the development and deployment of grid-scale storage to continue the enhancement of reliability, resilience, and flexibility. Stewarded by the Office of Electricity, this facility aims to secure domestic supply chains, independently test and validate grid-scale storage, and link basic material research to advanced prototyping, accelerating the testing and time to deployment of new energy storage chemistries. These are just a couple of examples to highlight the return on federal investments when utilities, academia, and national labs are able to collaborate and capitalize on the advances provided by fundamental research. And as our electrical system further digitizes and we become ever more reliant on electricity, it remains critical to continue to support innovations that protect our system from cyber and physical threats. Continued advancements through federal fundamental research combined with public-private partnerships to deploy advanced technology will enhance our ability to securely operate our nation's power system in real time, enable our grid operators to better avoid or reduce outages, and provide analytic tools for faster response, better mitigation, and more efficient planning for resilient operations. Thank you, and I look forward to questions.
Thank you, Mr. Fuller. I have to tell you that just from my background, I wish that this could go on for 6, 7, 8 hours. I would enjoy every second of it. But you probably wouldn't, and we'd never get anybody to come back and testify. So we will keep it within the allotted time. But very excited to have this today. And just to kick off, I recognize myself for 5 minutes for questions. Mr. Nelson, I spoke about 9 Mile Point. On my nuclear submarine, guess what? We had a nuclear reactor, we produced electricity, we had electrolysis machines, electrolyzers, but we took the hydrogen and pumped it overboard because it's explosive. But I have 500 days at sea breathing that oxygen that we created. I'm very thankful for it. So it's ironic we're now flipping that equation. Would you say what's happening at 9 Mile Point would qualify for the Inflation Reduction Act tax credit under Section 45V?
Yeah, thank you for that question. We think that nuclear and hydrogen is a great pairing for reducing emissions, as well as providing value to plants that might otherwise close. I can't speak specifically to 9 Mile Point, but in general, I think that plants should absolutely be looking at hydrogen as a way to provide more flexible operation when there are high renewables, and as a way to provide greater income for a plant.
Great, thank you. That's good insight. Dr. Boardman, of course, your facility's trained a lot of my colleagues, and it's well noted. Can't wait to visit. It sounds like what we should do is build some small modular reactors to kick off the hydrogen economy. Could you talk just briefly about the connection between advanced nuclear and the hydrogen economy?
I sure can, and it's a great subject because the advanced nuclear reactors is a game we can get into as a country, and those who get into it and succeed early will be the captors of the benefits that come to us. I could remark that states like Wyoming and Alaska are already considering frontiers where they see and want to implement these advanced reactors, and so it will be coming soon enough. And to pair those with hydrogen, many of the oil companies and other industries are looking at how this can be an on-site source of generating hydrogen because you have this concentrated, intense energy source 24/7, 365 days of the year that you can count on, and it's clean. So yes, we're in the process of understanding how those advanced reactors can couple to hydrogen generation, whether it's low temperature or high temperature electrolysis.
Mm-hmm. Thank you. Look forward to learning more about that. Mr. Johnson, we are challenged in our state of New York on pipelines. I'm thankful for what we have and wish that we had more. But your organization and the research that you've done, could you give us some ideas of how that's benefited consumers, the R&D into pipelines? Could you quantify that or describe that in a way that you think could resonate with average Americans who rely on pipelines to give them power?
Well, thank you very much for the question. It's a great idea to think about is how does research really give the benefits back to the public and the industry as a large? What you've been able to see through the work that PRCI has done is that we've been able to evolve the efficiency of the systems. Today, quite often, you'll hear the numbers of the 5 nines. 99.99% safe is our nation's infrastructure. What PRCI is about, though, is continuing to get that last 1/100th of a position and trying to be 100% safe. As we continue to do that, the safety and the integrity of these systems for most Americans is phenomenal. And if you think about it, most of us, let's be honest, don't think about where natural gas comes from, our liquid comes from. We're just happy to go to the gas station or turn on our lights. That's the resiliency of our current pipeline network through the research that we've done at PRCI to keep moving forward. So can I give you quantifiable numbers, Chairman? Unfortunately, I cannot. But I can tell you that we've seen a dramatic increase in improvement in safety and where we can be going and to enhance the quality of life for many Americans around the world. Thank you, sir.
Yes, sir. Thank you. I'm afraid I have time just for one more question. Mr. Fuller, you talked about a number of the technologies and techniques of cybersecurity for the grid. I've looked at that in for the industrial controls market, which is adjacent to what you do because of FERC and some of the FERC requirements. But other than technology and techniques, if you were to look at specific elements of our electric distribution grid, what areas would you say need our attention? What would you focus this committee's attention on? You know, is it transfer stations? Is it power gen? Is it, you know, transformers? What is the, where should we focus? Where are you most concerned if we were prioritizing?
Yeah, fair enough, and that's a challenging question to ask because there's a lot of challenges simultaneously. I think supply chain of either transformers or cyber equipment, both understanding what the root of those are and where they're manufactured, and understanding what that means to the system. I think anything that has to do with control systems and control networks and how we look at a more distributed control network rather than a big centralized plant, I think are all areas of concern right now.
Looking back from like the solar winds, and I see my time's up, but we'll continue, like I said. Thank you very much. I now recognize Mr. Bowman, sir, for 5 minutes.
Thank you, Mr. Chairman. My first question is for Dr. Boardman. Electrolysis has long been identified as a primary way to produce clean hydrogen. This process is commercially available, and currently billions of dollars are being spent on its advancement. What other promising methods have been identified to produce clean hydrogen with zero life cycle emissions, and what advantages might any of them have over electrolysis?
Yeah, Mr. Chairman and Congressman Bowman, you are correct that electrolysis has been around, it's been established. Alkaline electrolysis is well matured, but there are advanced forms of electrolysis using polymer electrolyte membranes. Those are nascent commercial, they're coming forth, and then there's the high temperature solid oxide electrolysis, which I've spoke. We can make improvements in all of these to bring down their costs of producing hydrogen by electrolysis. It comes down to the amount of electricity and the amount of heat and the cost of those materials. And the Hydrogen Fuel Cell Technology Office is funding consortia and research in these areas to bring down those costs so that it can be more competitive. Yes, there are other cutting-edge technologies for making hydrogen. Photoelectric hydrogen is one. There are thermochemical loops. A researcher at Sandia National Lab has come up with an idea, which I think is a good concept worth pursuing. So I would just close my remarks by saying that the Department of Energy is funding research on advanced hydrogen-producing technologies, and they show promise for the future.
In terms of these other methods, is it realistic to expect that any of them could be utilized in the next 10 to 15 years?
Yes. Yes.
Awesome. Thank you very much. My next question is for Dr. Ravikumar. Scientists have long reported that hydrogen triggers indirect warming effects in the atmosphere. Based on the latest understanding of those effects, researchers say its warming power is much greater than previously recognized. As a result, standard scientific accounting used in treaties and reporting requirements may be systematically understating hydrogen's powerful near-term warming effects. Which disappear after roughly 2 decades. However, climate impacts are usually calculated over a 100-year time frame, thus masking damage caused by escaped hydrogen in the near term. Can you speak to the significance of this oversight? Do we need to adjust how we account for near-term climate impacts?
Thank you for the question. Yes, we have to account for near-term climate impacts of hydrogen in any life cycle emissions calculations. The Department of Energy and other federal agencies have standardized methods to do this by looking at the global warming potential of different greenhouse gases. We have been doing that for methane emissions for a long time. We have to do that for hydrogen as well. The more important question in this area is figuring out how hydrogen will leak from natural gas infrastructure if you're blending hydrogen in natural gas pipelines. That's where we we need additional studies on thinking about what are the properties of hydrogen, how much does it leak, and what can we do in terms of materials research and sensor development to reduce leakage of hydrogen from natural gas infrastructure and dedicated hydrogen pipelines.
Dr. Boardman, anything to add to that?
I think he covered the subject pretty well, and I do believe that there is an opportunity to address all of these matters, and I think they are being taken under consideration, again, by the Department of Energy. You probably are aware that there is an interagency working group that involves all of our different branches of the government in looking at those particular areas, including the EPA, and I would just say my opinion, too, is that we need to do a well-to-gate emission study in each of these different options.
Awesome. One more question for you, Dr. Boardman. Hydrogen has long been lauded as a tool to address hard-to-decarbonize sectors such as construction and industrial production. These sectors are major employers for marginalized communities, but there have been concerns that hydrogen production could harm workers as well as surrounding communities due to problems such as leakage of nitrous oxide emissions. How do we ensure that these communities that we are hoping to help with high-paying jobs are not impacted with compounding health property risk?
Congressman Boyman, that's a very good question, and I would say that the answer lies in, first of all, understanding that maybe some of the risks need to be quantified. They may not be as big as we initially think that they are. At this point, hydrogen is already produced. It's transported in pipelines all across the Gulf shores, and so it is a mature system of using hydrogen. So we do have some experience for that already in communities. But in addition, we need to understand that hydrogen is an energy currency that can be put into sometimes better energy currencies, whether those would be ammonia, hydrocarbon carrying hydrogen, or even synthetic fuels that can take that clean hydrogen and put it into an infrastructure and combustible forms that we already have compatibility to use.
Thank you so much, and I yield back.
Thank you. I now recognize Mr. Barrett of Indiana for 5 minutes of questions.
Thank you, Mr. Chairman, and I do thank the witnesses for being here. Your expertise is really beneficial to our committee. But you know, one thing that comes to mind for me is Artemis. We're going to try to go to the moon, and then we're going to go to Mars. And the thing that was interesting, since we're talking so much about hydrogen, the fact that we found ice on the moon and we can break water or ice down to hydrogen and oxygen, and then that could be a fuel supply. So I'm not sure how many of you might be involved or interested in that, but that question comes to mind for me. So any one of the witnesses, you're welcome to make a comment about that. Starting with Mr. Nelson.
Specifically on ice,
Yes.
I don't have a lot to say on that. I would say that one other method of hydrogen that's quite interesting is that there are natural deposits of hydrogen underground on Earth that could be a source of completely emissions-free hydrogen that could be readily accessible, and there's a lot of interest in research into that. But I only have experience with terrestrial, not with space hydrogen.
Thank you. Dr. Boardman, any thoughts on your part?
Yes, Congressman Barrett, I can offer an opinion on that. And many times the thought is that we might have a scarcity of water resources here on this planet. And really it's, we have an abundance of water, and we can clean up water, including brackish water, to electrolyze and to make into hydrogen. We already use that water in steam methane reforming to produce hydrogen. So that's not a concern. But there are remote locations of which you're referring to where ice can be found, and you could then split that water to make hydrogen. And I would just refer you to an experiment in progress right now on Mars with Perseverance, where one of the companies, the U.S. companies that building this high-temperature electrolysis unit, has built a device to electrolyze CO2 in the very same manner. By splitting the CO2, they're producing carbon monoxide. When that ice is split and turned into hydrogen, now you have hydrogen and carbon monoxide, and you're off to being able to build many chemicals, methanol among them, and many fuels. And so it's an exciting opportunity to think about how these technologies, electrolysis being one, could co-electrolyze CO2. Now we can begin to turn our CO2 back into fuels and the things we use. That's closing the cycle of carbon, Congressman Baird.
Thank you, very interesting. Mr. Johnson, you got any thoughts?
No, we're basically just the terrestrial approach for pipelines. Not much in this space, sir. Thank you for the question, though.
And Dr. Arvin?
One of the things that's going to be helpful because of the tax credits that are available to hydrogen production here is that we're going to see a lot of innovation in electrolyzer improvement, both in cost effectiveness, efficiency, as well as miniaturization. All of these are going to be critically important when we are looking at hydrogen production in extraterrestrial worlds.
Yes. Mr. Fuller?
Again, like my colleagues here, I'm mostly on the terrestrial side, but I can see some opportunities where if you can have an abundant fuel source coupled with fuel cells, where you can use that for power production in a remote location, it couples nicely with the ability to not have to transport fuel across wide areas of space. So I don't have much more than that, though.
Well, I thank all of you for your comments. I really do. But my question now goes back to Mr. Nelson. The Investment in Infrastructure and Jobs Act, they authorized $7 billion for development of regional clean hydrogen hubs. The Midwest Alliance for Clean Hydrogen is submitting a final proposal that will clean hydrogen in the transportation sector, steel production, agriculture through ammonia production, and some of that's been mentioned here already today. So my first question is, what should our consortiums be doing to prioritize their proposals for hydrogen hubs? Should lawmakers be concerned about the use of taxpayer dollars?
Thank you for that question, Representative. I think it's really important that they're trying to find a wide variety of partners who have various expertise to make sure that projects are delivered on time and on budget. I think the Midwest Hydrogen Hub is a good example of this. It's a mixture of companies, national labs, and universities. But it's really important that they're bringing in the right balance of engineering experience as well as technical experience, and also making sure they have the right outreach to local communities.
Thank you, and I see I'm out of time, so I yield back, Mr. Chairman.
Thank you, Mr. Baird. I now recognize Ms. Lofgren, 5 minutes of questions.
Thank you very much, Mr. Chairman. This has been very interesting. I appreciate all of the testimony. I have a million questions, but I'm going to focus first just on one. As I said, just shy of 10 years ago, a team of gunmen opened fire on the Metcalf transmission substation in my congressional district. And just a few months prior to that, the National Academies released a report on the very topic of the grid being vulnerable to terrorist attacks. Now, physical attacks like this can lead to widespread blackouts, severe economic impacts, and I'm wondering whether we have adequately responded to this. Mr. Fuller, can you speak to how the grid was or was not fortified in the fallout from this attack?
Yeah, absolutely. Thank you for the question. And so immediately after that attack, as you mentioned, Chairman Wellinghoff led an effort that included national labs and another major experts that went and developed new standards for how to protect our power systems, particularly substations, how to fortify that against those kind of attacks. Those do take time. It's not something you can just deploy overnight, and it does, it costs money, quite honestly. And so it's an area that there is improved standards in those areas, but there is time to take that until those standards take in place and the equipment is actually in place.
Let me ask you this. At the time, there was a disruption, and it wasn't actually caught in an automatic fashion. There were just people watching, and they realized there had been a disruption, and they, as human beings, responded. Mm-hmm. Had they not done that, all of Silicon Valley would have been blacked out, and the estimates are that they would have been blacked out for a considerable period of time, creating disruptions not only to the economy, but given that a lot of the activity there is defense-related, would have had an impact on our national security. Has that been automated yet, or are we still relying on somebody paying attention and catching it?
Yeah, great question, and the answer is both. So there is additional automations, new sensors have been deployed, things even simple like watching oil levels inside of a transformer. But it's also new sensors like gunshot sensors to tell when a sound that's at a substation, you can actually hear what that might have been. So there have been new things that have been deployed to try to recognize these events. But in the end, it really is a good operator understanding that something is going wrong with the system and then making a decision to try to prevent it or mitigate it.
Now, I'm also thinking that in a case like that, redundancy would be our friend. There's vulnerability just because of the reliance on the way the grid is laid out in that part of California. Are we looking at or planning for or achieving redundancy to reduce our vulnerability?
Absolutely. That's part of the bread and butter of what utilities do in terms of trying to make sure that they understand where their most vulnerable contingencies are. They call it N-1 contingencies, where they're trying to look for where a failure will cause large-scale outages and then try to prevent those. The challenge is something like the Metcalf substation. Those aren't small investments, right? And they are quite costly to build a second one to be redundant. And so having instead supply equipment that can then quickly replace damaged equipment is probably a better approach than trying to build, say, a second substation along those lines. But of course, we're facing a shortage in transformers right now within the nation.
Let me just ask a final question. What happened with that attack? It was an attack on the substation, but there was also an attack on the fiber optics that was connected as the same group of attackers. Have we achieved adequate communication between the operators of the fiber optics and the operators of the grid so that that kind of information would be fed into the response? I mean, 9/11 was out for all the cities south of Metcalf for some time.
Absolutely, and I would say we're doing better. We're not there yet. So there is still a major reliance on fiber optic cables either owned by the utilities themselves or by third-party providers.
In this case, it was third parties.
Exactly, right. And so there is a need to continue that communication and understanding of what it means when you lose a communication system, have backup communication systems. In this case, you use typically microwave or things like that on top of a fiber optics cable. But there's more to go.
I was thinking more, not just the redundancy, but actually the disruption of the fiber optics preceded the gunshots and could have been part of the information into the operator in terms of what to do. But I see that my time has expired. I thank you, Mr. Chairman, for recognizing me.
Thank you, Ms. Lofgren. I'd now like to recognize myself for 5 minutes. I'd like to thank the chairman of the committee and the ranking member. The great state of Ohio ranks number 9 in the nation for farm operations, and 1 out of every 7 jobs in Ohio is in the agricultural industry, making agriculture incredibly important to me and my constituents. And as a member of the House Agricultural Committee, in addition to this great committee, I recently formed an Agriculture Advisory Council in our district to bring together the voices of farmers, livestock producers, agribusiness, and other agricultural representatives ahead of important discussions on the next Farm Bill. Mr. Nelson, have you seen any successful initiatives to support agriculture innovation within the federal government that will benefit key stakeholders such as the farmers and producers in Ohio's 7th District?
Thank you for the question, Representative. Look forward to working with you on this committee. Yeah, there have been a number of successful initiatives. One I would like to highlight is the Foundation for Food and Agricultural Research. It's FFAR, or it's pronounced FAR. It's a public-private partnership that pairs federal grants with private sector dollars. I think what's really interesting about it is that it does have a private sector matching requirement of 50-50, but historically it's been such a successful program that the private sector brings in a lot more money than is required. I think it's been about $1.40 from the private sector for every dollar from the public sector, and I think they've done a lot of work with Ohio State University, actually.
And they have a phenomenal campus down in Worcester, Ohio that we just visited.
Oh, really?
It's unbelievable, and the technology. Another point I want to touch on is the fact that carbon emissions from energy-intensive industrial sectors like steel and others make up nearly 1/4 of total U.S. emissions. Industry is looking for solutions but many currently available options are cost prohibitive and impede America's competitiveness with other countries. Mr. Nelson, how can we build on current policies and enable low emissions innovation while supporting strong American manufacturing industries?
Thank you for the question, Mr. Miller. I think we've seen in other countries, particularly in Europe, they've reduced industrial emissions by moving those industrial facilities out of the country. That lowers their emissions, but it also, reduces the number of jobs they have. The best way forward is to really develop newer technologies that lower the emissions of the products that we want to produce while maintaining those jobs. So, a great example of some legislation that's done that is the Super Act, which went through this committee, which is a comprehensive low-emission steel research and development program. I think you could follow that model for other subsectors of the industrial sector, produce those products with fewer emissions.
Thank you, and I yield back the rest of my time. I now would like to recognize Ms. Lee of Pennsylvania for 5 minutes of questions.
Thank you, Mr. Chairman. Focusing my comments and questions on hydrogen particularly, I think it's incredibly important to consider that while hydrogen is emerging as a clean and sustainable alternative to traditional fossil fuels, my greatest concern remains that we don't continue to marginalize the same communities that fossil fuels have. We have to be careful not to say that we're okay with communities like the one I'm from being sacrificial lambs in the name of energy innovation. We know that environmental sustainability and well-paying jobs are not mutually exclusive. Indeed, we need and we can have both. Research and development are essential to maintaining and upgrading our region's energy infrastructure. I remain steadfast in reaffirming that Pittsburgh's long and proud history of innovation will continue as we invest in research and development with a paramount focus on safety, efficient operation, and security for every community. With that said, Dr. Ravi Kumar, what research and development of hydrogen as a clean energy source needs to be carried out and tested in practical utilizations to eliminate the exposure of low-income communities, low-income and communities of color to disproportionate and adverse risk factors?
Thank you for the question. There are several areas of research that we need to focus on to ensure that we produce and use hydrogen in a clean and safe manner. The first thing to understand in terms of research needs for hydrogen is to figure out how does hydrogen leak from our infrastructure. So hydrogen, irrespective of what method it's produced by, whether it's from fossil fuel with carbon capture, whether it's from electrolysis or from nuclear energy, has to go into pipelines to go to demand centers. We have to do a lot more research in thinking about how to minimize leaks from pipelines of hydrogen. How does hydrogen, which is a corrosive gas, affects pipeline materials and building new materials to ensure that this infrastructure will stay safe for a long time. The second set of research needs that we have is hydrogen, when you burn them, burns much hotter than natural gas, resulting in pollutants such as NOx. We have to make sure that technologies that we develop that use hydrogen do not increase pollution emissions compared to current technologies. And this is something the Department of Energy and industry companies such as GE have been working on for some time, make sure that the pollutant emissions when we burn hydrogen are minimized and does not increase overall pollution burdens in the communities in which these facilities are installed.
Thank you. Also, as the majority of existing pipeline infrastructure is closest in proximity to communities of color, how can, and poor communities, of course, how can modeling be used in pipeline R&D towards the mitigation of the emissions impacts to communities that have historically borne the most adverse socioeconomic and health outcomes from the development of energy resources?
Right. One of the best things to come out of Department of Energy investments over the past decade has been in technologies that help us detect methane leaks out of natural gas pipelines quickly and cost effectively. We need to be expanding that program, especially as our infrastructure is aging, to make sure that leaks are identified as soon as it occurs and repairs initiated. In addition, several cities in the East Coast have pipeline replacement programs to replace aging infrastructure with newer, less leak-prone pipelines. We need to make sure that those pipelines are not leaking again. So a comprehensive multi-year monitoring program is critical to make sure that all of our infrastructure, both existing on natural gas side and new ones for hydrogen, do not leak over the next several decades.
Thank you. I have no further questions. I yield back, Mr. Shulman.
Thank you, Ms. Lee. I now recognize Mr. Keene of New Jersey for 5 minutes of questions.
Thank you, Mr. Chairman. Thank you to all the panelists for being here today and talking so eloquently about the need for innovation and working to get things done for both resiliency and making sure we have an all-of-the-above type energy strategy. Can you, Mr. Fuller, talk a little bit about what are the things that we need, what are the tools and the technologies that are necessary for industry to improve the strength, the resilience, security of the U.S. electric grid? How can DOE effectively partner with industry to identify and to address these technology needs?
Thank you for the question. And I think that is that partnership that you described, the public-private partnership, is the key to success in this area because it is a privately owned industry, right? So the supplies that are out there, we need to bring the technology to the utilities and help them provide a way to deploy it in a cost-effective manner. And so we talk about some of the most impactful things that we can do right now. A lot of this on the planning side to understand what is the impact of different events, how do you mitigate those events, and what technologies are the best to use. They're a way to basically cost compare and understand which you can basically get the most bang for your buck in terms of what's the right technology to deploy. But there's also the more on the ground technology, so energy storage of any kind, whatever the chemistry is a way to provide resilience to the system anytime that you're isolated from the system. There's also a significant amount of work that can go into even small sensors like wildfire prevention sensors, like drop sensors, where they detect that a cable has fallen from the tower and it is able to trip offline before it actually makes contact with the ground and therefore spark and start a new wildfire. So a lot of little things like there, but the more structural things pieces are, I think, the planning efforts to understand what is the best technologies and when.
Okay. As you may know, I come from New Jersey, and we've had our fair share of weather-related events over the years. What's the best way for us to all look at the resiliency, redundancy in all these energy development and energy transmission?
So I think a big part of that is to start to look at the system as an overall energy system. So exactly in the Northeast, a lot of that's tied to natural gas, supplying both power and heat to customers, and understand what that impact is when the system is stressed from multiple directions. So the North American Energy Resilience Model that I mentioned from the Office of Electricity is looking at just that. It's modeling the codependency of those two systems on each other and trying to understand how the stresses translate across the system, and then try to build in either whether it be natural gas storage or other mitigation methods to make sure that you understand how you can prevent those methods or challenges before they happen.
Okay. And to whichever member of the panel thinks they are best able to answer this question, in this all-of-the-above energy strategy, what role do you think hydrogen plays in the future of the U.S. energy infrastructure, and what synergies can be created with the other sources such as nuclear, oil, gas, and otherwise?
Yeah. Congressman, I'll take a shot at that question first. I think hydrogen has a very important role in a number of ways. One is to provide energy storage on long timescales. We've spoken to some of the PSEG in your state, and as we look towards building up renewables and wind turbine offshore, then the nuclear plants may need to flex. They may need to power down. Rather than powering down, they could produce and store hydrogen, which can be brought back and converted back into power with GE turbines or electrolyzers that are reversible. So energy storage plays an important role there. And we've talked to PJM about that particular option. Second, these electrolyzers may also be able to be used as a way to regulate frequency and power factor on the grid to help provide that resilience that's needed on the grid. And I would point you to some research that was done at the National Renewable Energy Laboratory with low-temperature electrolysis, in which they were able to modulate those very rapidly in order to mitigate perturbations of frequency on a grid. So it can also contribute to stabilizing and providing resilience to the grid when the system works cooperatively.
Yeah, Representative King, the other thing to think about too is that hydrogen is one of the next steps for us. And it's got to be an energy mosaic, as I said in my opening testimony, of looking at hydrogen, hydrocarbons. Any study out there you look at is going to take all the above to really get to our finish line. And hydrogen is a key component in that. we need to make sure, and go back to the comment that Representative Lee made, safety is going to be one of the driving factors as we move into this next evolution, is how do we do it safely and efficiently? And that's something the industry continuously works on and continues to drive forward on. So I think industry, hydrogen, it definitely has a key role. Now we need to make sure we understand it's all the above. It's not just one source.
Right, which is why, thank you for your time, and which is why I've been focusing on the all of the above energy strategy, one of the key component parts to make us energy independent. Thank you. Thank you, Mr. Chairman.
Thank you, Mr. Keene. I now recognize Ms. Ross of North Carolina for 5 minutes of questions.
Thank you, Mr. Chairman, and also thanks to the ranking member for holding this hearing and to all of our panelists for joining us. Grid security is a huge priority for my constituents in North Carolina. In the last 2 years alone, my state has experienced extreme weather damage, cyber attacks, and physical attacks on our energy infrastructure, all on a major scale. The Duke Energy blackouts over the Christmas holidays, the Colonial Pipeline cyber attack, and the Moore County substation attacks all left thousands without power or fuel. And these three events, as well as countless others that have occurred around the country, have demonstrated the urgent need for a federal government involvement and attention to securing the grid. We've had some questions about the sniper attack, so I won't talk about what happened in Moore County, but we really haven't talked much about cybersecurity. And this was a big focus in the last Congress, and I know there's some bills out there, including one that I have, that's passed the House and is in the Senate. So, Mr. Fuller, a report that the GAO released in March 2021 pointed out that the electricity grid's distribution system is vulnerable to more cybersecurity attacks, and that the report notes that the cyber attacks on foreign distribution systems, such as the 2015 attack on Ukrainian electricity facilities, demonstrate the vulnerability of distribution systems. In addition, national laboratory officials told GAO that cyber attacks on distribution systems could result in power outages of a national significance. What role should the federal government, and specifically DOE, play in increasing understanding of the potential impacts of a cyber attack on distribution systems?
Thank you for that question, and you're correct. This is a very important area to be working on right now. When you look at cybersecurity, this is not something that you can prevent everything, but you need to be able to prevent some pieces of it. You need to be able to mitigate it when it does happen. If you think about the way our system has worked for really 50 years, when a failure happens, you work around it and get the power back on. We need to be thinking about power system operations the same way when it comes to cybersecurity. So how do you reactivate the system when the cyber portion of it is compromised? That's what you're seeing happen in Ukraine, quite honestly, right? And what they're able to do very quickly and restand their system back up after continuous attacks. And so when it comes to the research side of things, there's a lot of capabilities in terms of trying to understand what the cyber risk assessment is. So understanding where are the vulnerabilities themselves, helping a utility understand all of that, but then how do you mitigate those, and which ones are actually the risks. Not all cybersecurity risks are actually something you have to worry about per se, but you want to be able to then identify which are the ones to focus on. Okay,
and Mr. Johnson, are there any particular research needs that the federal government can help fill to avoid a crisis like this? Each utility is going to be running its system a different way, and we have everything from natural gas to solar to nuclear. Where can the federal government help in a systemic way?
That's a great question. A couple years ago, there was a National Petroleum Council study that came out that talked about the cybersecurity opportunities and how the role of government is and industry. And really came down to that it really is a collaboration. It's not the DOE drives it by itself. It's not industry. It needs to be the sharing. As you saw when the Colonial event happened, it was a nationwide alert that went out rapidly. Elevating those kind of activities from a DOE point of view is going to be critical to our future to ensure the safety and integrity. So when you look at the research that's needed, a lot of it's being done already in a lot of different areas. Now it's a matter of the federal government helping coordinate and transmitting and sharing that amongst the industry effectively. Thank you.
And this is a last question for anybody on the panel. We know that we've given money to DOE through the infrastructure bill in order to do some grid modernization. We also know that FERC allows for cost sharing for grid modernization so that the utility pays some, people who might want to come onto the grid pay some, consumers pay some. A lot of states require all of grid modernization to be paid for by just the consumer. And so do you have ideas, because we have such great needs in this country, and we don't want some states to fall behind and some states to go ahead, for how we should do cost sharing? Anybody?
I can take a stab at that real quick. Yeah, I think utilities are very cost sensitive. They want to make sure that the rates that they're providing are as low as possible for their customers, and in many cases are required to keep them very low. So that sometimes means that for long-term investments on grid resilience, they might not make the largest potential investment because that would fall on those customers. I think the GRIP program in the IIJA is a great way for the DOE to help support utilities in making long-term investments that they might not be able to quite afford otherwise without substantially raising rates.
Thank you, and I yield back.
Thank you. I now recognize the gentleman from Texas, Mr. Weber, for 5 minutes.
Thank you, Mr. Chairman. Dr. Boardman, for you, and welcome to all of y'all for being here. In summary of your research activities, it states that your work at Idaho National Lab has led to a process that can solidify sodium-bearing nuclear waste. And I see you've been there since 1990 at the lab?
Yes, Congressman, I have 33 years now.
Well, bless your heart. As we work to unleash American energy, I believe that nuclear will play a critical role in that. Research and development in this space is critical. So I want you to share how your research can lead to nuclear playing a larger role in our nation's energy portfolio. But before you do, in 2017, I was able to pass the NECA Act, Nuclear Energy Innovation Capability Act, that said to the Department of DOD, make your research dollars, get into the next round of SMRs, small modular reactors. You know that China and Russia is eating our lunch on nuclear, and that's unacceptable. Were you aware of that bill, Dr. Boardman?
I'm not aware of that specific bill,
Okay.
Congressman Weber.
Well, it got signed into law by President Trump, but we didn't wind up getting spondula for it, and that's a Texas word for dinero. So how is your research going to lead to nuclear playing a larger role in our nation's energy portfolio?
Thank you, Chairman Williams and Congressman Weber. I'm excited to answer that question. And first off, let me remark that when I started, I was working with that sodium-bearing waste and helped develop processes, and a process will start up very soon now to treat the very last part of that sodium-bearing waste. But as we move forward with these advanced reactors, first of all, we are looking at extending the life of the existing fleet, and it provides us an opportunity to continue to use that for the electrical grid and maybe even beyond. So there's a program called Flexible Plant Operations and Generation. It's funded under the Light Water Reactor Sustainability Program.
Let me break in for one quick second. Have you given thought to maybe some suggestions for the NRC on updating their process? I'll yield back to you.
Thank you, Congressman Weber. Yes, and I think that's very important. And so part of the work that we're doing is actually to help NRC understand how both the existing fleet and advanced reactors are going to be able to interface with the hydrogen production plants. A lot of work is going on right now where we're looking at probabilistic risk assessments, failure modes, and effect analysis so that we can be on top of being able to help these plants, existing and future plants, very quickly couple with hydrogen plants. So that's part of the research and development that is underway. Now, just as our history has been to build and improve nuclear reactors, that work continues, and we're now set to start up 3 more reactors, and we hope in the future that through the National Innovation Reactor Center, NRIC, that we'll be able to continue to test and prove these advanced reactors, both at the Dome facility and as well as a new facility that we're speaking much about now called a proving center. These proving centers are very, very vital to us to be able to show that in a place where we're very familiar with nuclear energy, like the NuScale reactor, like the X-energy reactor, like the microreactors that are coming out. And so I think we're on track right now to accelerate the demonstration of these reactors at a place where we have a lot of people who can do that, and then they can quickly leap into industry. And it's important for us to continue that work, and we're happy that we're orchestrated in that cause.
Well, thank you. I've had some conversations with some of the members on this committee in days gone by, and one of the comments was if we could show nuclear to be safe and efficient, or that they would be in favor of nuclear power. And my comment was, I can prove that nuclear energy is safe, efficient, a good form of power with 2 words: nuclear submarines. We put nuclear reactors in a nuclear submarine. We put under the water in a boat or submarine that might be 400 to 500 feet long. I forget how wide and how tall it is. And then we load it up with, 90, 100, 110 of our finest Americans. And then we put it under the water for what, 2 or 3 weeks at a time. Does your work, are you familiar with that style of nuclear reactor?
Yes, Congressman Weber, yes, very familiar with that style. And I would comment further that Pele is a program in which the military is now helping to advance the use of these new nuclear reactors. And if they can do that for military purposes, we can use them for civilian purposes. And that is coming together in states like Wyoming and Alaska, where there are state and military and commercial entities coming together.
How many submarines does Wyoming have?
Not too many, I don't suppose. But I would imagine they've sent a lot of officers to the Navy, and we appreciate that state for all they do.
So it is coming together. Well, thank you for that. And, Mr. Chairman, I yield back.
Well, I appreciate those comments. I now recognize Mr. Sorensen from Illinois.
I want to thank Chairman Williams and Ranking Member Bowman for convening the hearing, and thanks to our witnesses today. In 2022, I purchased my first electric vehicle. It was an important decision for me as a climate communicator and a meteorologist. I represent parts of northern, western, and central Illinois, Moline, Rockford, Peoria, Bloomington, Normal. The problem that I have as a congressman is I cannot drive my vehicle from my home in Moline to the corners of the district and then make it back home. The infrastructure just isn't there. Not only does the physical infrastructure not exist, the electric grid is, as currently constituted, is not capable of supporting the number of chargers that we need for Americans and the people in my district to drive an electric vehicle tomorrow. And so for Mr. Fuller, what steps can Congress take to accelerate the upgrade that we need in the grid to support electric vehicle use on a worthwhile scale?
Yeah, absolutely great question. And I bought my first one in 2019 and have the same challenge. It's very difficult to get to Seattle and back for me in one charge. So I feel your pain there. But one of the things that can be done is there's programs like Electrify America and things like that that are deploying stations across the interstate highway system, allowing for fast charging stations. In this case, a DC charging station network that's allowed to faster charging. There's also then starting to look at some of the long-haul trucking, which is going to be a significant impact on the power system itself when you're talking about 5 to 10 megawatt chargers for each truck. And how do you move across the country that way, recharging those stations? So I think the investments that the offices are doing right now in terms of trying to understand where to place those things, actually putting money into pushing them out there as a public charging infrastructure, are all wonderful things. I think starting to look at what it's going to take, what are the storage and local generation needs that are going to have to happen to make sure that these kind of big charging stations are going to be able to exist without having to upgrade the network itself, because you don't want to be tearing up roads and trying to deploy new lines to support them. And so there's kind of a whole series of events that are going on right now that I think are moving in the right direction, but we can keep accelerating those.
Forgive the pun, it seems sometimes that we're spinning our wheels here. On our current trajectory, when do you think I'll be able to advocate for my constituents to buy an EV?
It's a tough question. I really don't have a good answer for you on that one. I know that we've done some studies that are looking about the energy resources that are available. For example, in the Western Interconnect, we can serve up to 28 million vehicles just immediately right now. As long as they're done with smart charging, we can actually get up to 65 million vehicles. These are all consumer vehicles, not big trucks and things like that. So as the energy is there, it's about getting it to the right places and then being able to build out the infrastructure to support it. It took us, 50, 60 years to build a gas infrastructure to be able to actually then drive gas vehicles along. How long will it take us to do the electric vehicle infrastructure? I hope a lot faster.
Thank you for that. Dr. Boardman, I'd like to continue a couple of the questions that Mr. Weber, my colleague across the aisle, had asked. The state of Illinois is a leader in nuclear energy. The problem that we have today is that developing a new nuclear reactor is cost prohibitive for our electric companies. How do we make sure that that small-scale nuclear can be paid for? Is it public-private partnership? Or what do you suggest?
Yes, Congressman, I believe that it is, and it is the key that we have those public-private partnerships, that we begin in the beginning to talk to the supply chain. So those advanced reactor companies begin to look at manufacturing done in by U.S. companies, so that we can establish, just like any other infrastructure, a high volume of manufacturing, and then we can turn towards factory assembled, factory built, field assembled. So we've got to come up with concepts that allow us to bring those costs down in the way we do with every other industry. And I do believe that efforts are underway with those partnerships that are now looking at that.
And I look forward to the partnerships across the aisle for this clean energy, and I yield back.
Thank you. I recognize Ms. Foshee for 5 minutes.
Thank you, Mr. Chairman, and thank you to the witnesses for being here with us today. The severity of the cost of extreme weather in the United States is growing, and the role that climate change plays in these events is being further studied and better understood. We do know that as climate change continues to accelerate, weather will become less predictable and extremes will grow even more extreme. I see this firsthand in my home state of North Carolina, where the hurricane season has pushed our state's energy grid system to its limit on multiple occasions. So my first question is to Mr. Fuller. Mr. Fuller, grid planners need a sharper understanding of how climate factors could affect the performance of their systems beyond simply expect the unexpected. So can you talk about what research investments and coordination are needed to improve our grid resilience planning?
Thank you. That's a great question. There's a lot of really great work coming out of the Office of Science that is looking at climate modeling and understanding and predicting what the new system will look like going forward. We're really talking about 10, 20, 30, 50 years out and trying to understand what that is. But translating that to extreme weather events is a challenging piece. And then what we call downscaling that to local weather patterns to understand what do you need to get ready for. There's a gap there still in terms of trying to understand that. There are a number of national labs that are working on that effort right now to try to understand it. And that allows utilities to then say, not just look at past historical information to understand how they should build their system to prevent outages, but look forward to say, okay, here's the weather patterns that we are expecting, and therefore we can design to protect ourselves from those things.
Thank you for that. Is it your sense that utilities have the tools that they need to consider various scenarios in order to anticipate the potential physical impacts on the grid?
I don't believe so at this time. So, this is something that's different than the past, and so they need the tools to be able to understand what the future is going to look like. They know how to design their system. They build it and they run it cost effectively for 100 years, but they need the tools that help them understand and predict what that system is going to look like going forward, particularly the weather patterns that are a part of it, where floodplain is going to move, where our heat waves going to occur and how often. And so that's a gap right now, both in the availability of certain data sets that allow them to understand and make that prediction and then adjust their planning around it.
The rapid addition of advanced technologies to the grid highlights the need for workforce development and training in both the grid resilience and cybersecurity sectors. So again, Mr. Fuller and later, Mr. Nelson, is there a role for the federal government to fill this gap? And if so, what would that look like?
I think the answer is absolutely. There's a severe shortage of qualified workers in cybersecurity and in power system operations that's been ongoing for, at least in power system, for over 20 years now. And so we do need to basically build out that workforce and have them ready for what the next challenges will be. There are programs like the National Security Internship Programs that help young students get into STEM programs and stay in STEM programs, and then assist in the federal investment cycles. They're all good ideas, and we should, I think, continue to invest in those and find ways to expand those programs, particularly focusing on some of the STEM applications.
Mr. Nelson.
Yeah, absolutely agree with Mr. Fuller on this. This is a critical area where we're not going to have enough folks working if we don't have specific investments. One interesting program at DOE is the SunSpec Alliance, which works on trying to provide jobs in cybersecurity related to solar and distributed energy for military veterans. I think we should be trying to find ways to try and couple our workforce development programs for cybersecurity with also trying to support veterans and other people who need good employment opportunities.
Thank you. And with that, Mr. Chairman, I yield back.
Thank you. And now we have Mr. Caston from Illinois. Representative Caston?
Thank
you
you,
have
Mr.
5
Baird.
minutes.
Thank you, Mr. Baird from Indiana. Thanks to all our witnesses. So I want to talk about hydrogen, and forgive me, I want to get nerdy here, but it's sort of what I do. There's an existing market for hydrogen for, as a fuel source in NASA. There's an existing market as a hydrogenation agent, as a chemical. Stipulate all those are interesting and not the reason why everybody's investing in hydrogen. There's a future market that is, number one, how are we going to decarbonize the hard to decarbonize industries where we use fossil fuel as a reduction agent, basically, right? So, can we replace met coke in a steel mill? Can we replace natural gas in an ammonia plant? All good. And this committee, I'm very proud to say, we passed 2 years ago the Clean Industrial Technology Act, funded again, really, really important stuff. The sex appeal, if you will, is on the electric side. And Dr. Boardman, one chemical engineer to another, I want to focus on you because we make laws here all the time, but we don't get to change the laws of thermodynamics. So I want to just run some first law math and tell me if you disagree with this. Electrolyzers currently 60 to 70% first law efficiency. Is that a fair number?
Yes, that's a fair number for alkaline and alkaline electrolysis.
Okay, and cutting edge breakthrough best in class electrolyzer, what are we talking about, 90% maybe?
Congressman, we can exceed that. We have test units running in Idaho right now, fully integrated systems that are reaching 90%, and there's opportunity for improvement.
Okay. So that takes us from electricity to hydrogen. To then get the hydrogen into a compressed or liquefied form where we can transport it, 90, 95%, maybe as low as 85% if we're going to go for liquefaction. Do you buy those numbers?
I do.
Okay. And then if we're going to get that hydrogen out to the point where we're going to use it, fuel cell, depending on what technology, 30, 60%?
In some cases, yes. In some cases, it could be higher.
Okay. So I run through that math because if we're looking at, and let me take your 95% number. If we're 95%, 85% on the compression, and 60% on the fuel cell, that's a 34% efficiency at turning electricity into electricity.
That's correct.
So the argument for doing that versus putting electricity into a battery and turning it back into electricity, which is like an 80% round-trip efficiency, is premised on, I don't see how that math works unless there's a compelling reason why it is cheaper to store and transmit hydrogen than it is to store and transmit electricity. Right?
Thank you, Congressman. Yeah, that is an important discussion, and I think a lot of this will come down to also the capacity and the amount of energy that might be stored when we have excess generation from the renewables that get built up, come when the wind blows, come when the sun shines, And how can we move that?
Sure, but that's still an electricity to and like we could, I mean, that's a capital cost question, right?
Yes,
But,
it is.
But if we're sitting there saying like, you know, if money's no object, I can build a lot of storage of one form or the other. But at some point, I'm going to care about those marginal operating costs to determine which of the capital gets built.
You do need to take account for that. So, Congressman, we have done some calculations here, and I think that's a very important question. We agree with you. The math needs to be studied. And in cases where the amount of energy that needs to be stored gets large enough, then the capital investment in the hydrogen and the efficiency starts to pay off. So it's a systems calculation that needs to be considered.
So if I could, and I'm nervous about the time, and I told you I was going to get nerdy here, I'm with you on that logic. Have there been any meaningful advances in hydrogen storage in the last 3 decades? And I say that because 20 years ago, I was part of the Hydrogen DOE Technical Advisory Task Force. And we said there's compressed hydrogen, there's liquefied hydrogen, and then we're really excited about metal hydrides and carbon nanotubes, which didn't really materialize. As far as I can tell, years ago we were talking about 8,000 PSI canisters, and now we're talking about 10,000 PSI canisters. Are we, number one, do we agree that storage is the pacing technology? And if we do, are we spending enough dollars in storage? And is there actually a plausible technology, even if it's just on the corners of somebody's physics notebook, that's out there? Or are we still basically just putting pressurized gas in tanks?
Congressman, I'll try to answer that the best I can. There are new technologies. The Pacific Northwest National Laboratory is working on one that would use magnetics to try to compress and liquefy the hydrogen. There are opportunities to put it with other forms, put it into ammonia, put it into methanol, put it into synthetic natural gas. Those forms of hydrogen storage would probably be much easier. And these are systems that we need to evaluate. We need to do the cost. But the storage options might include putting it into other forms of hydrogen carriers and compounds.
Well, I'm out of time, but as you can tell from my comments, it just seemed to me like for decades, storage has been the only meaningful question, and I'm not sure we've really answered that. And we can get all the sex appeal tied up in everything else, but if we don't have a good answer to the storage question, we're just throwing a lot of dollars at something that doesn't pencil. Thank you. I'll yield back.
Thank you, and I don't believe we have any more questions, so I really want to thank the witnesses for being here. I know that takes time out of your busy schedules, and it's really helpful to have the kind of expertise that you have to share with the members of this committee. So on behalf of the committee, I want to thank you for being here and sharing that kind of information. I must say that the record will remain open for 10 days for any additional comments and written questions from members. And so with that, this hearing is adjourned.